Assalamualaikum dan selamat sejahtera. Okay, here is the lecture for topic 3 part 1, that entitled Industrial Energy Management. Okay, this is the outline for this topic. Okay, there are 5 subtopic, but for part 1 I will focus on power loss in industrial power system and loss reduction, and also energy efficiency in industrial power system. So the other 2 subtopic will be covered in part 2. Okay, first we go to power losses in IPS. Okay, there are 2 types of losses in IPS, which are technical losses and non-technical losses. Okay, for technical losses, losses occurred in the electrical element mainly comprised of ohmic and iron losses. Okay, mostly depends on electrical loading. Okay, for non-technical losses, okay, the losses is due to theft of energy and unrecovered bill amount, also called as commercial losses. Okay, first we go to technical losses. Okay, there are 2 parts. The first one is current dependent, and the second one is voltage dependent. Okay, for current dependent, mostly is in series losses, but for voltage dependent, mostly in shunt losses. Okay, for current dependent, mostly the types of losses is copper losses. Okay, we just focus on the copper losses. Okay, but for voltage dependent, there are 3 types, which are iron losses, dielectric losses, and corona losses. Okay, next we go to the power losses flow. Okay, the first one is power transformer. Okay, this power transformer has losses and it depends on the efficiency of the transformer. Okay, from the transformer, connect to the feeder using power cable here. So power cable also have losses, which is determined by I squared R. Okay, and then feeder also have their efficiency, this one. Okay, and then from the feeder, the outgoing from the feeder will connect to the load. Okay, the first one is lighting, the second load is motor loads, and the third load is heating elements. Okay, all the loads are connected each other by using power cable here. Okay, and also power cable have their own losses determined by I squared R, and all the loads have their own efficiency here. Okay, efficiency for motor and also efficiency for heating elements. Okay, line losses are a fault of passing current through an imperfect conductor such as copper. Okay, the line losses can be calculated based on the measured current load S. Okay, this is the formula for losses, P losses, which is equal to this formula, which is equal to I squared R, where I is the current, R divided by L is resistance divided by kilometer, L is the length of the cable in kilometers. Okay, for a 3-phase system, the losses for each phase are calculated separately according to the measured current as P total, P loss total is equal to P loss A plus P loss B plus P loss C. Okay, this is the formula for the P losses for 3-phase system. Okay, assumption made. First is all load currents maintain a constant ratio to the total current. Okay, the voltage at every source bus remain constant in magnitude, and also lastly power factor remains constant. Okay, it is not possible to measure the distribution losses incurred by individual customers due to many unexpected losses factors such as network utilization, network configuration, the shape of the load profile, and the level of reactive power support. Thus, an estimated losses calculation approach using load factor and also load losses, this one is load losses factor, is introduced. Okay, next we go into detail what is load factor and also load loss factor. Okay, first we go to load factor. It's a ratio of average demand over maximum demand. So this is the formula for load factor. Okay, load factor is equal to average demand divided by maximum demand. Okay, and next we go to load loss factor. It's a ratio of average power loss over power loss at maximum demand. Okay, this is the load loss factor. Okay, actual loss, this one. Okay, the unit is kilowatt hour, actual loss, divide by loss at maximum current in kilowatt hour. Okay, the relationship between LF and LLF. Okay, this is the relationship. You can see here. LLF is equal to K times with LF plus 1 minus K, okay, times with LF squared. Okay, where K is a constant, okay, typically 0.1, 0.2 or 0.3. Typically, K is equal to 0.3 for sub-transmission system, okay, and then K for 0.2 is for, okay, this one, for medium voltage feeders and distribution substations. Okay, K is equal to sample section of network can be analyzed to introduce an estimate of the K factor applicable for the rest of the system. Okay, next, loss in a feeder for a given period, which is 1 month in this case, is given by technical losses is MU. By this formula, this one, this and this one, this formula. So this is the formula for technical loss in MU, where I is the load in ampere, R is the resistance of the conductor in ohms per kilometer, L is length of the feeder cable in kilometers, LLF is the load loss factor, and yearly technical loss for 3-phase feeder in MU is equal to, okay, this formula. Okay, this one is for yearly technical loss. Okay, next we go to loss reduction methods. So there are some methods that we will use to reduce the loss. The first one is proper sizing, and then we have regular maintenance, and then we have convert LV to HV lines, and then we have to minimize overload, okay, and then we have to improve power factor. Okay, next we go to subtopic energy efficiency in industrial power system. Okay, there are energy efficiency here is used to reduce consumption, and then to reduce carbon dioxide emission, and then to improve the reliability of the power system, and lastly is to optimize the cost of the operation. Okay, here is the energy consumption by sector. We can see here for transportation there are 27% use, and for residential 60%. For commercial only 8%, but for industrial there are 49%. The highest energy consumption sector is industrial. Okay, and Europe's target 20% reduction in CO2 by 2020. Okay, this is the method how to increase energy efficiency. The first one is reduce energy use. Okay, only use energy efficient device or equipment. Okay, this one, and proper control and monitoring all the load, and use variable speed drive. Okay, next, save energy cost. Okay, by using proper production planning to avoid peak hour charge, and use automation system in the plant. And lastly, energy reliability. Avoid energy losses. Okay, we have to avoid energy losses, and proper maintenance. Okay, we have to do maintenance frequently, and treat PQ properly. Okay, this is some of energy efficiency classes for LV motors. As we can see here, EFF1 4 poles. Okay, this is the graph. We can see that EFF1 4 poles has the highest efficiency compared to others. Okay, we can see from nominal value from 1 up to 90 kilowatt still have the highest efficiency here. Okay, this is the energy saving based on reducing fan speed by half. We can see here there are two types of speed. The first one is fixed speed, and this one is the variable speed. Okay, we can see for 50% here. Okay, the percentage of P is almost 20% for variable speed. Okay, this one. And for fixed speed, we can see that the percentage energy is about 80%. So we can see that for variable speed, the percentage of P is lower compared to fixed speed. Okay, this is the load management strategy. Okay, this strategy is important to make sure that the industry will pay for the bill is low. Okay, we can see here, this is the time, kilowatt versus time. Okay, this is the usage of the energy. Okay, we can see increase and reach the peak demand. And when the peak demand is reached, and it will make sure that the peak demand is scheduled to keep it below a given threshold here. This is to make sure that the peak demand will be reduced and the bill is low. Okay, this is the monitoring architecture for a small site. You can see here there are some PC here. Okay, for installation monitoring. Okay, there are some software that will be installed. Okay, and then there are power incomer here, and also some of the Modbus for internet. Okay, and this is all the load that will be monitored. Okay, this one, all the load that will be monitored by this PC. So this PC will make sure that all the load used is not reach the maximum peak. Okay, next we go to energy saving tips for IPS. Okay, for energy saving, we just consider 5 item here. The first one is the lighting, motor, compressed air, HVAC, and refrigeration. Okay, this is the load that will be used for industrial. Okay, first we go to energy saving tips for lighting. Okay, first replace incandescent lighting with compact fluorescent lighting indoors and outdoors. CFL is almost 4 times as efficient as incandescent bulbs and lasts about 12 times longer. Okay, the first one we have to replace. And the second one is for outdoor lights, use a timer or photocell so they turn off automatically during the daylight hours. Okay. Third, for indoor lights, adjust lighting level. Okay. Okay, next, take advantage of natural light by placing work areas near windows. Okay. And lastly, install occupancy sensors so lights go off automatically in unoccupied rooms. Okay, next is energy saving tips for motor. Okay, we have 4 tips here. Okay, the first one is when purchasing a new motor, choose the most energy efficient one you can afford. Premium efficiency motors cost about 20% more. Okay. Second, select a lower power motor and operate it at a higher load factor near optimal efficiency to help justify the motor replacement. Okay, third, using a variable speed drive motor system instead of traditional motor when loads vary significantly over the course of daily use. Okay. And next, lastly, optimize transmission efficiency by using synchronized belts instead of V belts. Okay, next we go to energy saving tips for compressed air. Okay, there are 4 tips here. The first one is reduce compressed air cost by analyzing compressor operation and reducing leaks. Okay. And second, use a system approach while operating and maintaining a compressed air system. Okay. Next, implement a company-wide compressed air. Okay, this one, compressed air management policy to eliminate unnecessary use, fixing leaks and synchronizing use with supply and demand. Okay, lastly, smaller compressor can be used to operate during unoccupied period. Okay, next we go to HVAC, which is heating, ventilation and air conditioning. Okay, this is the tips to reduce the energy. The first one is reduce, okay, this one. First one, reduce the facilities load, allowing the existing system to operate less frequently. And then, implement of an energy management system. Okay, this one will be control all the load that used by HVAC. Third, set zones to return off exhaust fans when not needed and control the temperature of space at night. Okay. Number 4, okay, consider energy recovery ventilation system to reclaim waste energy from exhaust and use it to condition the incoming air. And lastly, we have to combine a dehumidification component to HVAC system. Okay, for last item, refrigeration. Okay, this is the tip how to reduce the energy. The first one is regular maintenance, okay, of refrigeration components such as coil, fan, seals, etc. Will help keep the system running at its design efficiency level. Okay, and then we have to check temperature setting to ensure they are not lower than necessary. Okay, and next we have to keep refrigeration system out of area that have frequent fluctuation in temperature areas, indirectly sunlight or away from outside doors. Okay, and then we have to install a variable speed drive. Okay, this one to control the level of refrigeration necessary to keep items cool. And last, we have to defrost cycles can be reduced by adding a sensor at a evaporator and by running defrost at night. Okay, I think that's all only for part 1. Okay, topic 3, part 1, and we will continue for part 2.